Welcome to SolidWiz. Today we pick up the topic of the render outputs and how we can optimize the speed for rendering animations, for example. And the main origin of this question is one comment which I got, and it was a question: can you make a tutorial on animation output optimal settings? Sometimes it takes me forever to render a short animation of 15 seconds. So I think everybody of us know exactly this situation, but there is some help. There are some options how we can optimize exactly these topics. And also for the future, if you have a question, if you have a problem, just place it in the comments and I will try to pick it up for a tutorial like we do it here. So stay tuned. And we are back, so welcome to this tutorial about the output settings and the optimization. First of all, we will take a look at multiple options which could play a role. We will run some experiments, and this means we will render quite a lot of images. And don't be confused, I all the time skip the rendering time, so it looks like everything renders like 1 second on my computer, but don't be confused about that. So first of all, I prepared exactly according to the question, to the information I got, this Excel sheet that we can compare all the optimization steps. One of them will be the render passes. We will talk about the tessellation, which is some kind of the resolution of the model. Then material details, depth of field, motion blur, and we have an automatic calculation. And also here we see again the 15 seconds which were marked in the question. So we simulate a 15 seconds animation. I just expect that everybody is rendering more or less with 30 frames per second. So this is in total 450 frames, which just means 450 images. So this means down here, when we have, for example, with this simulation 50 passes, let's say 30 seconds, it automatically calculates and we end up with 3.7 hours for the complete animation. So this is how it works, this is how we go now, and first of all we pick up the render passes as I focus with talking on. So let's jump directly into Visualize, because later we go into Solidworks for other settings which we can set up. So let's take a look here. Everybody knows this environment, and the render activation is here. And already now we have one important point, because by default denoiser is activated in my system. I think it's by default. So all the time it's the talking about that the denoiser is 10 times faster. But if you don't change the settings according to the denoiser activation, then it's at all not 10 times faster. It's exactly the same fast, or maybe even a bit more. The reason that it is 10 times faster is that it needs much less render passes, and this results finally into 10 times faster. So we keep it activated. And usually in the past, before the denoiser, you needed to have 200 render passes, 500, 1000, and so on. So let's take a look here. What I have set up, I just simulate a 1K resolution with 1920 and the 300 dpi's. And when I go a bit lower down, I have here the simulation of 25 render passes, and I just follow my sheet here with 25, 50, 150, 200. So let's stay here and keep the 25 active, and actually that's already good to go for the first rendering. of this image. And from an old tutorial, I added some surfaces on the metal that it looks quite realistic. I have the focus point also in this area, so let's take a look how it comes out. And we directly go into the rendering, and for now we will also skip it, so just see you right now. And we are back. I could actually stay here because it only needed 5 seconds, and it directly saved my image in the render passes folder, so this is correct. And we will take a look later at the results because we just jump into the next one, which is an experiment, and I add here in the 25 render passes to 5 seconds. So we would need 37 minutes for the 15 seconds animation. That's not quite a lot, so let's jump into the next one because we need to take later a bit detailed look into the quality of the images. So start render the next one. We are out of the rendering with 10 seconds, so place it here. I don't know if you have seen it, but the surfaces already look quite a lot different compared to before with detail grade. So let's pick the other one, and then we are very close to the comparison. So now I go with the 100 render passes, and let's start it. And we are back again with 16 seconds output. So let's place the 16 seconds. We already end up in 2 hours of rendering time for the complete animation. And now I even did a mistake here. So let's jump over to the 150 passes. And we will directly stay with this. So let's close this. We inserted the amount of seconds. We jump over to the next one. And we go with the documented 150 passes, render. And this time we come out with 23 seconds. And maybe you are already asking yourself, why the hell is he doing this? So we already have now 4 images, and you will directly see why we have this. I just pick a last one for safety with 200 render passes to show you more detailed why it is very important that you run these experiments always before you create an animation, because you will invest maybe 10 minutes for this preparation, but finally you can save 10 hours, 2 hours, it depends a bit to how long your animation is. So go for this experiment all the time when you do an animation, especially when you have not a too strong machine in the background. So let's run the last one, and out of this rendering we come with 30 seconds. In the meanwhile, during the 30 seconds, I just added the last column with 200 passes. So let's insert 30 seconds. And you directly see in here with the lowest amount of passes, we have around about a half an hour to render the 15 seconds animation. And with 200 passes, we end up close to 4 hours, which is a difference. So from this to this with a potential saving of 83%. But it's not only about saving time, so it's also about keeping the quality. And this is exactly what we try to take a look now. So I go into the first image. I have to render in the right row. And when I go to the right, you directly see the difference between the images is available. And you also see, this is also a very good point, focus on textures and focus on the shadows, it gets a little bit more noise in the 25. So 25 is actually out of the game, because when you render it with 25, then you just have a noise down there. It always flips a bit and it flickers, and that's why we don't take the 25 for sure. But let's take a look between 50 and 100. So when I go from left to right, I see a little bit of the correction in the shadow. So this could also end up in a flickering, and the surface is actually not really doing that much, a little bit. So we already are at 0.3 with 100. So the 100 is at the moment the pick. So let's go to the next one, 150, switch back 100, 150, and actually I don't see anymore a big difference. So this is already a good sign. I don't see a difference in the shadow. I don't see when I switch, here you can see the numbers, between 100 and 150. So this is already a very good match. And this means also when I jump over to number 5, which is the 200, and I go back to 150, we don't see any difference. But when you look in the sheet, we don't see a difference in the quality, but we see a difference in the time. So even when I change this calculation between the 200 and 150, we saved 23% of the time, but we don't get any more detail grade, any more quality. So it's definitely not worth to go with this one. And the first one, which had not really a visible change, was the 100 passes. And there we have from the 200 passes, for example, a saving of 50% of the time. And for me personally, just for the safety, I always like to go with the first one, which looks the best, like the same like the next one. And I just add 50 on it, on the top, to be on the safe way. So in this way, I would pick the 150, but if you really have trouble with rendering, you could go in this case with the 100 passes. So let's mark this one with green and change the calculation. So already here, when we look at 200 passes, we have a saving here of 23%. And if you render even higher with higher passes, then you will save here quite a lot. So this is one thing I always recommend to do when you run an animation. Go in the most complex sequence with depth of field, with materials on it, with as most as possible parts on it, and then you see exactly how many passes you will need, and you can really render it with the lowest possible passes to get the highest possible quality. So like that, don't add 200 passes and think, yeah, like that I'm safe. You will waste a lot of time of rendering. So the next topic will be the tessellation. I'm not sure if everybody knows this hidden option in Solidworks, and I directly say Solidworks because it's not controllable in Visualize, it's directly done in Solidworks. So let's take a look at this one. I just prepared here a simple dummy model, and what you need to do to take a look at this one is go on this wheel of the options and directly switch to the document. And when you go to the qualities, sorry to have it in German because I always need to translate it. Very soon I will switch it over to English. So here you can set up like you see it in circle. When I go low, you see it not really round. When I go high, it's round. And these options up here are directly transferred into the Visualize, and you cannot change it in the Visualize anymore. So we will just run one example. I go to the lowest point. By default, Solidworks is set up to the middle. So I would really wonder in the comments if you knew about that one. So let's pick the lowest one. It directly changes the model. For sure it renders much faster then. But when I go to the Visualize export and it opens, resume rendering, and I directly switch to the camera which I have set up. I go to a bit more complexity and activate the depth of field. I pick a focus point, this ring here, and then we are ready. And you see a bit, there is not a perfect circle around overall, so let's add some material to it, just how they are out of the box, because then we directly have some comparison for it. So depth of field is activated. Backplate is a bit disturbing, but I just keep it in there. And we go with these terrible circles into the rendering, and finally we will see if there is an optimization or not. So let's go into the Tessellation folder to place the renderings, to split them. I go with the same settings, but this time with, let's keep it on 200, then we have a better comparison, or 150 was good to go. So start render, and let's see how long it takes. And finally, this ugly result took us 7 seconds, and you see here in the surfaces, this is something what you don't want to show a detail shot of. So let's directly go back to SolidWorks and try to make it look more nice. And never forget to insert the seconds that we have something to compare. So we are back in SolidWorks and we go into the camera view again. So go back to the options, document options, and the image quality, we increase it this time to the middle, or let's directly go to the highest one, so in the red area, and everything gets perfectly round. So again, we do an extended export. We don't want to re-import, no save. And we come into Visualize with a beautiful round part. Switch the camera again. Then turn on depth of field to make it a bit more complex. Like we did before, we pick the focus on this ring here. We switch over to library, do exactly the same with adding the scratch metal. And you directly see it get perfectly around the model. And now it's the big question, do we save time by reducing the tessellation of the model, or do we don't save? So open the rendering, go exactly with the same settings into it and render it. And we are back From the rendering, it looks already much better with the result, and we end up with 8 seconds. So let's take a look again. It's very good that I didn't take the medium one. So when I insert 8 seconds here, I just need to adapt it to the right column. We have a potential saving of 13%, and for sure we don't know the detailed seconds behind here. Last time I came out with around about 10%, so it's a bit of saving possible, but not too much. Now another experiment is, for example, the material detail, which we can do. So for this I go back to Solidworks, to Visualize, sorry, and we just apply, instead of the scratch metal, which has a bump map in the texture, which makes it a bit more complicated, I just add a simple aluminium. And we do exactly the same rendering with exactly the same settings. So let's start it. Directly jump over. We were on the high tessellation, so we kept this one. So with the high resolution we had 8. Now let's see how we have the output with the low amount, and we come out again with 7 seconds. I should have taken a bigger resolution to get a bit more detailed time savings. So we are at 13%. Now let's do again, we had depth of field and high material detail with 8. So with depth of field 8, and when we go back to SolidWorks Visualize, then I can just press twice Ctrl Z. Exactly, and we go to the camera, and this time we turn off the depth of field just to get a feeling, does the depth of field has an influence with the denoiser or does it not. So I deactivate it, render again image, start render, and finally we come out of this rendering with 8 seconds as a result. So let's take a look, 8, and also here we have 8. So with the depth of field in this simulation we have 0% saving potential, and this is also my experience in the past before having the denoiser. It was crazy how it impacted the render speed, the depth of field, but the denoiser can handle it very good. And another simulation, what I want to show you is the motion blur, because maybe you played around with it, maybe not, but it can also impact probably the render speed. To show what the motion blur is, I just open a video from the past where you can see very good what it means to use the motion blur. So let's open it, and what we have is at second 4. I remember here we have a very fast movement of the camera to the part, and it gives some movement and dynamic into the image, so it makes a blur according to the movement, and this is the motion blur. I really like it. I don't use it very often, but it's just great when you have fast moving parts, when you have fast moving cameras, and then stop to a part and focus on the detail, then it can be used very good. So let's take a look how this impacts the rendering, and just go back into Visualize. To show you more details, the motion blur, I made here a small camera movement into the animation, and in the middle of it we are moving over the parts in here, and because of the movement we will have some kind of a motion blur. So at the moment the part depth of field is over here. Here it's a bit unsharpened, and when I go into the camera and go over to the advanced settings, I can use the drop down of the motion blur activated, and depending on the speed it gives some left right blur into it. So let's see how it impacts the render speed. So let's go for the same one, and we come out of this rendering with 29 seconds. So let's place it in here with motion blur, 29 seconds. But maybe what I missed, the image seems quite high resoluted, so no, it's still the same. I'm surprised about the result. So let's do exactly the same rendering without the motion blur active. Resume rendering, and now it needs to remove the motion blur, and we do the same rendering again. And also out of this image we come with 29 seconds. So let's place here 29 seconds, and then we are ready with the analysis where we can save time and how we can save time with the animation. So let's take a look at the render passes. I don't have the information how many render passes were used in the endless 15 seconds rendering. So it depends a bit, but for example, if you were going with 400 passes, then you can save a huge amount of time. If I just compare the 200 and the 150 passes, the 100 passes were also some kind of okay. So even in this way I can switch it, and there is a potential saving of around about 50% of the time. And also in the tessellation we have seen the results. We can just take again a look at the result. If I didn't miss it, no, here is the tessellation. So we had the tessellation in here with the round variant, and here with the not round variant. So if you think between these two, if you are very far away from a part, you don't have round parts in your animation, then sure you can optimize a bit, but is it really worth to go 10% faster just to have this kind of result? I think not. So I would definitely skip the tessellation. And also one thing you need to know, the tessellation is not that much impacting the render speed, but it impacts extremely if your computer can manage the animation. So it's really a big deal for your memory, and I observed it in the past when having just one graphic card in my computer. It crashed quite often. So in this case I would always go over, or I just always go with the high one, and I'm not really looking for an optimization. And what we have observed is that we can save a minimal of time in the material shaders. So if you are far away from the parts, you can maybe reduce the details of the surfaces. but definitely then you need to invest more time for the close shots and for the far away shots, and then you can also ask yourself, is it worth to save around about 10% for this? I would directly go with the high one. And also down here we see we had no single saving. So the main answer for your question is take a look at the passes. That's an immense saving potential what you have, and you can take a look at the tessellation, maybe save a little bit of time when you go with the medium, because the medium really also looks okay, but never go with low because you just destroy your work. And the material details are a potential that you just go with a lower detail grade, especially when you don't have a close shot of it. And if you run a close shot, then just go with it. And this is actually the summary of this tutorial. It was quite a long story, but I hope it helped you a bit to how to look around, where to look around, how to find out how you can optimize your render output, and more tips I at the moment don't have in my pocket. So take a look at this, and definitely I would be happy to get an answer if it helped or not. So feel free to write it down in the comments, and also if you have additional questions, just mark them down. So thanks a lot for listening and have a nice evening. Bye.